Okay, so my name is Rodolphe Marques. I'm a software engineer at a company, a Swiss-based company called Kiko. Um, and I'm a lead architect for one of our products, which is called Nevermind, and which is what I will be presenting today. And I want to focus most of the presentation in a live demo. I won't be going through all of the slides. I just left them here for the sake of completion so that anyone who wants to learn more after the talk and when the slides are published, they can find a bit more information. Um, so an overview of Nevermind so that we can understand what will be going on in the demo. The main purpose of Nevermind is to enable data ecosystems. And a data ecosystem can really, it's a really broad term, but you can think of a group of companies coming together to solve a common problem. For instance, you could have a group of banks from a particular country that decide to work together to tackle credit card fraud, or it can be even the same bank that's spread across multiple jurisdictions and has no easy way to really take advantage of the data that they own because of data compliance or privacy reasons. Can also be the number of freighters in a supply chain. Um, or it can simply be someone that has data and wants to monetize it with no other purpose. And then on the other side, you have companies or data scientists that want to train their models to solve a specific problem, but they don't really have access to data. So this is the problems that we're trying to solve. And Nevermind does this by integrating with the existing data architectures. Uh, and basically provide an interoperability layer which allows the different actors in the ecosystem to buy, sell, share, and run computations over data. Uh, so and Nevermind does builds on three main building blocks. One is the data sharing ecosystem. The second one is the what we call data in situ compute. And we will be focusing on these two topics. And the third one is a data marketplace that allows individuals to advertise and buy and sell data. So I'm gonna skip to the architecture. So this is the kind of a simple overview of the architecture for data access on Nevermind. Um, we have the gateway, which is the basically the main point of content for clients. And this gateway is run by data provider. So each data provider needs to run this component. And the gateway then communicates with other Nevermind components that deal with the data. Uh, and we also use blockchain, and I think I'm going to be a bit proactive here and already answer the questions, which is why we use a blockchain. And we have several reasons for that. One is it's our areas of expertise. It also makes it easier for us to settle payments and basically attach payment conditions to other events on our solution. Um, it also makes it flexible to enable different data monetization use cases. It provides immutable record of the interactions between all actors in the ecosystem, and this can be useful for later audit or even conflict resolution that may arise in the future. Um, and it also eliminates the need to rely on a trusted third party to mediate the interactions between ecosystem actors that don't necessarily trust each other. So in the simplest case of data sharing, we have some provider that advertise some data to Nevermind. So the data doesn't leave the provider and it doesn't need to change. So we just integrate with the existing data architecture. And what happens is that the provider will advertise some data, a client will find it through some marketplace or data catalog. It will request access to the data, after basically locking the funds to access the data. And the provider, if he wishes to accept, it will give the client access to the data and redeem the funds. So the client never has direct access to the data. Everything is mediated through Nevermind. So if we take this one step further, we want to solve use cases where you want to monetize your data, but you don't really want to share your data. That's losing a lot of control over your data, or also sometimes you simply cannot for data compliance or privacy reasons. And we introduced a new component, which is a compute orchestration framework. And basically what this does is it allows data consumers to, instead of having direct access to the data, they can publish algorithms that will then be executed over the data. And these algorithms can be anything, can be machine learning, can be data analytics. And the orchestration framework, what it does is that it creates a sandbox execution environment where it connects the data with the algorithm, and then it publishes the results of that computation, which are then sent back to the client. So then we take this one step further, and as a data consumer or as a client, I'm not restricted of running an algorithm on the data set of a single provider. Nothing prevents me from running the same algorithm over multiple data sets and doing this in parallel, doing some sort of distributed computation. And this is really where federated learning comes into play. So in this case, the client has its machine learning code, and it will basically request the orchestration of a federated learning session that will run over the data set of multiple data providers. So for the demo, the use case that we're going to showcase, so imagine we have two different data providers that provide an image data sets. Here we're using Cypher 10, and basically what we did was split it in two. So each provider will provide half of the data set. And as a data scientist, I basically want to train a model to do some image classification over those both of those data sets. And we will show the data in situ computation of Nevermind, which focus on basically bringing the algorithms to the data so that the data doesn't have to move. And what we will show will be the data provider flow, which is how, as a data provider, I can advertise and monetize my data to Nevermind. And as a data scientist, how I discover the asset, I purchase services associated with the asset, in this case, compute service, publish my algorithms, define my workflows of how the algorithm should be executed, and finally execute the federated learning session and getting back the results. So I'm gonna now move on to the demo. Just want to make sure that I have everything running. Yes, I do. So I'm gonna start by executing this because it will take some time for this to take a couple of minutes for it to execute. So first of all, let's go to the machine learning code. So we're using Flower as our federated learning framework. So basically what we're doing is that we're start by loading our data and we basically create an NumPy client using Flower, where at the beginning of each round we set the weights. Here I'm just selecting a small subset of the data for time's sake. I run my fit method and my evaluate method, and I basically start the client. So this client will be running on both data providers. And then we have our server, which is it's just a bare bone Flower server with just specifying the number of rounds. So one thing to note here is that there's really no Nevermind specific code here, and this is by design. So the idea is if you already have some code running, you should be able to run it on Nevermind with little to no modifications. Here, the only real Nevermind code that you will see is just an environment variable. We expose some environment variables in the execution environment that you can use. And in this case, it just gives you the path for the inputs, which, as I will show, are just serialized NumPy arrays. So from a provider side, what we do is we have each provider has its data set hosted somewhere. In this case, we're using GitHub. So as a provider, I start by instantiating our Python SDK and our account. And then I'm going to publish our data sets. And basically, an asset on Nevermind is just metadata that defines what the asset is about. We have multiple types of assets. In this case, it's a data set. And here we're only setting the required fields like name, date of creation, and price, and the type of asset. But of course, in a real case scenario, you should have more information like about what's the schema of the data or what's the features available and so on. And then for each file in the data set, we add it to the metadata. And in the end, we get a document or metadata like this with all the 4 files from our Cypher data sets. And then we actually advertise this to Nevermind. So we have 2 main shortcuts to create assets on Nevermind. The create compute means that I'm creating an asset with a compute service attached to it. So I don't have direct access to the data, but I can run computations over the data. And we get a globally unique identifier on Nevermind. And then we do the same for the second data provider, which will publish the second half of the data set. And we will use a third provider here, which doesn't provide any data. It just provides compute. And we're going to just pay for this compute just to run the Flower server. So this is the flow for providers to advertise their data. It's basically define the metadata and publish it. Now I need to copy these identifiers. Okay, so here I'm going to do the same. I'm just going to execute the entire notebook. So this is now the consumer or the data scientist flow. It starts by getting the assets through some marketplace or some data catalog. The assets that he wants to use or the services that he wants to consume. So we have 2 data sets and we have a compute provider. And then we have our algorithms that we want to run. In 2 of the providers, we want to run the Flower client, and in the third provider, we want to run the server. So I start like previously by setting up the Nevermind SDK, with the main difference that now I need to fund my account because I need to make the payments for access to the data in the compute. So the first step that we have to do is to publish our algorithms. And this is similar to publishing a data set. In this case, our algorithm is going to be the Flower client. And we need to specify a bit more information for the execution environment. So the entry point details how the algorithm should actually be executed. And in this case, we just start by installing some dependencies, and then we use Papermill to execute the Jupyter notebook directly. And we also specify where we want the output. So it receives a Jupyter notebook, and it will create an output, which is also the same Jupyter notebook, but now with the cells filled with any outputs that were created. And we can also define a couple more requirements. In this case, the only requirement we have is just a stock Python 3.8 image. And of course, there's multiple ways of publishing an algorithm. Here we have only one file, but we could easily package everything in a Docker container and then just use that for more complex use cases. And here we have the metadata for our algorithm, and we get an identifier. And then we repeat the same process for the server, and we publish that algorithm on Nevermind. And now we come to the part where we define the workflow. So a workflow basically defines how the execution of the algorithm should happen. Think about a workflow in Nevermind similar to a continuous integration workflow, something like GitHub Actions or Circle CI. So in this case, we will have a workflow that has only one stage, and it has as an input, it will have one of the data sets, and as a transformation, it will have our algorithm for the clients. And this is the workflow for one of the providers. And then we create pretty much the same workflow, but for the second provider, so the algorithm remains the same. We're just using a different asset. And then we will have the workflow for the Flower server. So we have no input, so we're not consuming any data in this provider. We're basically just running the algorithm, which is the Flower server. So once we have all of this created, so we published our algorithms, we also published our workflows, and now we're actually going to request access to the service provided by the data providers. So I start by ordering compute access to the data for both data providers. So the service type that I'm looking for is the computing service. And in this step, we create a service agreement, and we basically lock the funds. So this service agreement will then be used by Nevermind to check that all the conditions are there, that the consumer actually has access to execute a computation, and so on. And then we order the compute for the third provider, which is just compute, and we run the Flower server. So now that we have everything in order, we already paid for the server, we already have all of our workflows, we can actually go ahead and ask to execute the workflows. And here we start by executing the workflows for both data assets and for the server. So now we have an algorithm, or in this case, 2 algorithms running in 3 data providers in parallel. And then we can just monitor through the SDK. We have several ways of monitoring the jobs and getting the logs and so on. And we can take a look here. This is part of the compute orchestration stack of Nevermind. So this is something that the provider runs in their infrastructure and they have access to. So here we have the 3 compute jobs that we triggered. We can check them. So each compute job has 3 stages. One is the configurator, which sets up the execution environment and basically connects the algorithm to the data or brings them together. The transformation is the actual execution of the algorithm, and we can take a look at the logs. So it basically starts by installing the dependencies, and now here we're running in this case, it's the server. And once this finishes, we will have a third step, which is the publishing step, which takes all of the outputs of the computation and publishes it so that the original consumer or client can download them. So we can take a look at the other jobs. So this should be one of the clients, so it's the same. So here we can see some of the statistics at the end of each round. And yeah, now we need to kind of wait a little bit. This usually, it should be close to finishing. So So if we go back to the Jupyter notebook. So the last step is just waiting for the compute jobs to finish, and once that happens, we will get back the results. So this should probably take another minute or two. I would open the floor for questions while we wait for this, if there are any. Javier?
Yes.
So while we wait, if there's any questions, I can answer them.
Yeah, we have a couple of questions. I think they look like maybe short questions, but first question is, what kind of data is already available in the Nevermind marketplace?
So Nevermind doesn't have a marketplace, or Nevermind is not a data ecosystem. It's just a framework and a set of tools to enable you to build ecosystems. So we don't have one data ecosystem or data marketplace where we provide data. There can be many data ecosystems, and consortiums are built around it. So we're basically tackling the last step, or actually bringing the compute to the data, or actually tackling the federated part in federated learning.
Okay, so if, for example, we take as an example like the typical federated learning experiment, where we have maybe Cypher 10, we have 100 clients, the task is to learn a good global model, right?
Yes.
Where what's the task here? Can we use the Nevermind blockchain infrastructure for that task as well, or?
Yeah. So here we will be. I think the main use case is for data that is more sensitive. So we had use cases with banks, like the credit card fraud detection, where we have multiple banks that kind of want to take advantage of all of their data to train better models instead of using only the data that they have available. That would be one use case. We also had use case with supply chains, where this wasn't so much about machine learning, but it was about data analytics. For instance, for the shipment of COVID vaccines, we would use Nevermind to basically run data analytics on top of the temperature sensor data to make sure that the temperature always remained within a certain threshold during the trip. And this data could be you could have insurances that would pay to get access to the data. So that's another use case. So I guess in summary, you would have a group of companies that will come together and build an ecosystem using Nevermind to tackle a common problem. And what Nevermind provides is an interoperability layer that allows them to share and run computations over the data, regardless of whether their data architectures will be different.
I see. Okay. And is there, like, final quick question, is there any possibility that there might be like a malicious actor that would take advantage of, look at these enterprises sharing this data, maybe there is a malicious actor that subscribes to the blockchain and can extract some of the data? Is that even possible?
So no, so Nevermind itself never actually sees the data, and Nevermind itself doesn't publish any data. So the data never leaves the premises of the provider.
Okay.
So whatever infrastructure they're using, it's the same, whether they have data on premise or on the cloud. What Nevermind does in that case, it just works as an access or a decentralized access control layer to basically allow clients to access the data under certain conditions. Can be payment, can be something else. So we never actually deal with the data itself, or never actually have to look at the data. I guess the closest that we get is the compute framework that actually needs to access the data to run the algorithms, but that is also run on the provider's infrastructure.
Okay, I think that was the last question we have. I don't know if you, I think maybe your experiment's finished, Ryan. You want to conclude?
Yeah, so basically our experiment finished. So we get the outputs of each one of the 3 compute jobs, and we already downloaded them, and we can check them here. For instance, this is the same Jupyter notebook, but now we have the cells filled with any outputs that we used here. It's just simple metrics, but it could easily be the model weights or whatever we choose. And yeah, that's it. This was the demo. I hope that it was a bit short to do everything in 30 minutes, but I hope that it was enough.
Yeah, I think it was very good. Like seeing real life demos in action is always difficult, and I think it worked out pretty well. So thank you.
I have some links here, and probably this will be published. The presentation will be published. So if anyone wants to learn more about this, they can join our Discord server, which is the easiest way to get in contact with us.
Okay, thank you very much, Rodolphe, and thank you to all the speakers in this second session.